Hello there students, welcome to part 2 of the vector series. In today's video we will be covering dot product, the properties of a dot product, and we'll do some practice problems. Suppose that we have two vectors, vector A and vector B, written in their component form. We will now find the scalar, or the dot product, also known as the scalar product of vector A and vector B. A dot product of A and B is written with a dot in between vector A and B, signaling or indicating that this is a dot product. And so to find the dot product of our vectors, we'll multiply each corresponding component of A multiplied with the corresponding component of B, and then we'll find the total sum of those components. And so multiplying AX with BX and then adding it to AY, BY, adding that to AZ and BZ. We can now see that the dot product of two vectors will give us a real number. Hence why it's also known as the scalar product. Suppose we have two vectors, vector A and vector B, and we want to find the dot product of these vectors. As mentioned previously or before, we will now multiply the corresponding components of each vector. We start by multiplying the first component of vector I with the first component of vector B in the x direction. So that's -1 multiplied by 6, adding that to the second component of vector A, multiplying it with the second component of vector B. So that's 7 multiplied by 2, adding that to the third component of vector A, which is in the z direction, with the third component of vector B, -1 multiplied by -6, we get -6. 7 multiplied by 2, we get 14. And 4 multiplied by 3, we get 12. We get 26. And then get an answer of 20. And so as we can see, our final answer is a real number. And so that's why it's also called the scalar product, because it gives us a scalar at the end. Let us now cover the properties of the dot product. The dot product of two vectors that are the same will give us the absolute value of that vector squared. So suppose we have vector A. Suppose we have the dot product of vector A. This will give us the magnitude of vector A squared. Dot products are commutative. What do I mean by this? Suppose we have vector A, the dot product of vector A and vector B. This is equal, or can be written as the dot product of vector B and A. Third property, the dot product is associative over addition. So as we can see here, we've got the dot product of vector A and B plus C. B plus C can be treated, or is, a single vector. You can refer to the previous video on how we found this to be true. And so we'll treat B plus C as a single vector. This is equal to the dot product of vector A and vector B plus the dot product of vector A and vector C. The dot product allows the distribution of a scalar. Suppose we have a scalar which we'll name C, being multiplied with vector A dot vector B This is equal to the scalar multiplied by the dot product of A and B, and this can also equal to vector A, the dot product of vector A with the scalar C multiplied by vector B. The dot product of a null vector, also known as the zero vector, with a non-zero vector, this will give us 0. Suppose that we have a zero vector or the null vector, the dot product of the zero vector and a non-zero vector, which we'll name A, this will give us a value of 0. Suppose that we have two angles that are in the first quadrant, vector A and vector B, such that there's an angle between these two vectors. If we want to find the angle between two vectors, if we have two vectors in the first quadrant such that there's an angle in between them, and we want to find the angle between these two vectors, we know that the dot product of A and B will equal to the magnitude of A multiplied by the magnitude of B multiplied by cos theta. And solving for cos theta, we find that cos theta is equal to the magnitude of A and B, the dot product of A and B over the magnitude of A multiplied by the magnitude of B. Suppose we have vector A and vector B, and we want to find the angle in between these vectors. We'll first find the dot product of A and B. We'll multiply the corresponding components of vector A with the corresponding components of vector B, multiplying the x component of vector A with the x component of vector B. We'll multiply the y component of vector A with the y component of vector B. And lastly, we'll multiply the z component of vector A with the z component of vector B. Two times 1 gives us 2. 3 times 5 gives us 15. 4 times 2 gives us 8. And adding these three together gives us 25. We will now solve for the magnitude of vector A. To find the magnitude, we take the square of each and every component squared, and then we'll find the sum of those components that we have squared. 2 squared gives us 4, 3 squared gives us 9, and 4 squared gives us 16. Adding these together, 25, gives us square root 29. I'll move this over there to make space. We will now solve for the magnitude of vector B. It's 1 squared plus 5 squared plus 2 squared. We have squared every component that is found in vector B, and we've inserted it under the square root. And so 1 squared gives us 1, 5 squared gives us 25, and 2 squared gives us 4. 29, it gives us root 8. Our final value gives us square root 30. I'll move that over there to make space. And so now we have every value that we need in order to substitute into the formula such that we can calculate the angle between these two vectors. Cos theta is given by the dot product of A and B, which we have found to be 25, the magnitude of vector A, which we have found to be root 29, and the magnitude of B, which we have found to be root 30. Plugging that into our calculator gives us 0.84. And transposing the cost to the other side, such that we're left with theta and substituting that into the calculator, we get a final value of 32.86 degrees, meaning that this is the angle between our two vectors. Two vectors are said to be orthogonal if their dot product is equal to 0. Two vectors are said to be orthogonal or perpendicular if their dot product is equal to 0. So if we have vector x, the dot product of vector x and vector y equaling to 0, then it means that these two vectors are orthogonal. So let's draw it graphically to illustrate. If the dot product of vector x and vector y equals to 0, then it means that there is a 90 degree angle between vector x and vector y. We have now reached the end of the video. Thank you for watching. Make sure to subscribe, like, and follow for more.